So today we'll be looking at this is a summary of today's discussion. If you have okay, let's say we have some liquid there, and then we have an object lying flat at the bottom of the liquid, at the bottom of this liquid. So this liquid here will be exerting some pressure, okay, on the surface of this solid. It will be exerting some pressure there, okay. So on today's discussion, we'll be looking at number one, what is the pressure? How much pressure does this liquid here on top of this surface exert on the object? Then number two, we'll be looking at the center of pressure, okay, of pressure. Why does this pressure act? Where's my eraser now? Where does this pressure act? Or you can say the position at which this pressure will be acting. So that's it for today. So now, the pressure which will be experienced by this flat, it is horizontal, okay, by this flat object will be, the pressure which it will experience will be given by, first of all, the pressure will be given by one, the weight, the specific weight of the liquid, okay, this, because this it is, the pressure is caused by the mass of this liquid, which is directly sitting on top of this object here, okay. So the pressure will be given by the weight of this liquid multiplied by the surface area of the solid multiplied by the depth, okay, of the center of mass of the given solid. So we're talking about how deep this depth is given by, is given as it is for how deep is this object immersed. This is the height, okay, x bar. So the pressure will be given by the specific weight of the liquid, the surface area of the solid, and the depth of the center of gravity of the given object. This is how we're going to be calculating the pressure, okay. And then the specific weight, we know that specific weight is the density of the liquid times the gravitational constant. And for water, we know that for water the density is 1000 times the gravitational constant is 9.81. If you multiply this, you get 9.81 kilo for 1000 Newton meter cubed. This is the specific weight. Hello, there's someone who wants to say something? Is someone who wants to say something? Morris, you
No,
okay.
I'm following.
Okay. Yeah, so for water, the specific weight will be given by this. Then the area will depend on the type of object which is immersed, okay. So for example, the area of a circle, it is pi d squared over 4, or pi r squared, which this is equivalent to pi r squared. This is the area of a circle. So you should know also the kind of object that you're dealing with. Okay, is it a circle, is it a rectangle, or is it a triangle, all that you need to know. Then let's go now to the center of pressure. The center of pressure, okay, is given by h bar. So the point at which this pressure is acting will be equal to h naught over surface area times the depth, where the h naught is equal to the Ig, which is the moment of inertia, plus the surface area of the object multiplied by the depth squared. So where there is I naught in this center of pressure, we can substitute by this. So we saw that we can have the Ig plus the surface area squared, then everything over Ax bar. This is x bar. Then we can simplify this as Ig over Ax bar plus Ax bar squared over Ax bar, so that your center of pressure will be given by, this is h bar, by the moment of inertia g over surface area times the depth plus, we can reduce this, we can reduce this out, okay, so that we have, and also we can also reduce the a's, the surface areas there, they're common, so that we can end up with the x bar. So this is the formula for the center of pressure. This one here, this is the formula for the center of pressure, and then this is the formula for the total pressure exerted by a liquid for a horizontally laying object. Okay, yes, so this is the summary of today's class. This is everything. So let's do an example. Let's look at an example. From our slides, from our notes. So and then before we do an example, let's discuss this table here. So this table that you're seeing here, from it we'll be obtaining the center of gravity, or the point at which the pressure is acting. So now these formulas that are here only works in situations where they I have to switch again the screen. Okay. Only works when we have this situation here. When you have that, let's say this is okay, and then we have an immense object, okay, and then this part of the object is tangential to this line, okay, to the surface of the water, okay, it just touches right there. Then there's a distance from this point. This is the center of the object, where the center of mass is acting, and there's a distance from the surface of the water right at the circumference to the center. Okay, this distance here is represented by x bar, And now those formulas in the table, they only work when you are measuring from when the object that you have is touching the surface of the water. So for example, for the circle, okay, from the table, for the circle, the x bar is given by the diameter of the circle divided by 2. And obviously the diameter of the circle runs from this point, running through the circle, through the center, all the way to the other point. This is the diameter of the circle, and half of the diameter is just the radius. And you can tell from here that from the center of the circle to this point, that length is simply the radius, and that's why we have d over 2 for the circle. If we had a situation, a scenario like this, okay, suppose we had a scenario like this. This is our circle, is just right there, and then the surface of the water is here, okay, and then this is the radius at this point. That is our radius. Let's limit r. This is our radius. Then from this point to the surface of the circle, to there, let's say this is some distance, which y, okay. Then our x bar will be given by, first of all, because x bar you measure from the center of gravity, from the center here, will be r plus the y, the distance from here to there, and then from there all the way up to the surface of the liquid. Okay, so the x bar will be given by r plus y. So you need to be careful about the position of the immersed object. You need to be careful about how it is immersed, how far the center is. The center is from the surface. Yeah. So in the table, the assumption is what I've just explained in the table. Is that the assumption is that we are measuring part of the object is touching the surface of the water. So for a triangle, to find the x bar, you get the height divided by 3. Of course, the area of the triangle is b times h, and then the center of the moment of inertia will be given by b times the height cubed over 36. For a rectangle, the center of gravity will be acting at a depth of d over 2. The area of the triangle is b times d, and then the moment of inertia will be given by b times d squared over 12. So you have to know these formulas for a circle, for a rectangle, for a trapezium, for a triangle. Okay, so let's go now and do an example. Let's do an example. So in this example, the question is saying that calculate the plate of diameter. A circular plate of diameter 1.2 meters is placed vertically in water in such a way that the center of the plate is 2.5 meters below the free surface. So this one is direct. They're saying the center of the plate is 2.5 meters below the free surface of the water. So this one you are given directly, like the x bar is 2.5 meters. So determine the total pressure on the plate, the position of the center of pressure. Okay, total pressure on the plate and the position of the center of pressure. Let's go back to our whiteboard. Yes. So the question is saying that number one, we are given an immersed, okay, circular object that is not very round, and then we're saying that from the center to the surface, this is 2.5 meters. Okay, then the diameter of the, so this is our x bar. Then the diameter of this circle is 1.2 meters. Number one, find the total pressure. Find the total pressure. So what do we need here? First of all, we need to find the specific weight of what liquid is this. This is water. The specific weight of water is 9.81 kilo Newton meter cubed. Okay, this kilo is for 1,000. This one here. Okay, so and then this area of this object, which is circular, will be given by pi d squared over 4. So let's substitute pi multiplied by, and the d is, the diameter is 1.2 squared over 4. That is our diameter over 4. Then if you get your calculator, you put in the numbers. I will have my calculator with me here. I'm going to say pi. I'm going to say pi. Then times 1.2 squared. You are going to get 1.130973. Sounds like a phone number. 355. Okay, so this is not the time to round off. This is not the time to round off. Write everything in full. That's your surface area. Then the x bar is given to be 2.5. So it's just a matter of now substituting. Let's substitute on the side here. So the pressure will be given by, the W is 9.81 multiplied by, the surface area is 1.13. This is not the time to round off. 0.97335 multiplied by the depth of the center of the object is 2.5. So the pressure will be given by, if you multiply this to be times, it will be 9.81 multiplied by 2.5. So the pressure will be given by 27.73712154 kilo newtons. Okay, so now at this point you can round off to 3 decimal places. 27.737. This is kilo newtons. So the kilo is for 1,000. So this number can also be written as 27737. I'm copying from here. Okay, 123,000 point 121 newtons. It can be also written like this or like this. That is now the pressure. Next, let's look at the center of pressure. At what point does this pressure act? So the center, number 2, the center of pressure, which is given by the moment of inertia, the surface area, the depth. Okay, like that. So we need to look for the moment of inertia for what object? For a circle. So you go back to the table and get the IG. Well, and for a circle to be given by pi d power 4 over 64. So we can have pi, this is pi, then our diameter is 1.2 power 4 over 64. So evaluate that on your calculator. You should get multiply 1.4 0.2 power 4 over 64. Okay, so this is given 0.1017876. So this is not a time to round off to. So let's substitute now. Substituting here, our center of pressure will be given by 0.101787602, everything over the surface area. We found it to be 1.13097335 multiplied by 2.5 plus 2.5. So if you use your calculator very well, you're going to realize that that will be 1.13097335 and then 55, then multiplied by 2.5 plus 2.5. Okay, so the point at which this pressure will be acting will be at 2.36, okay, meters. It will be acting at 2.36 meters. So let's go back to our diagram. Okay, so it is just right below, it is somewhere right below the center of the given circle. Okay, it is somewhere here, right below the center. So the point of action of pressure is always below the center of gravity. So whenever you calculate and you find the center of pressure is above the center of gravity, somewhere here, just know that your answer is wrong. It should always be below, somewhere below the center of gravity. Do you have any questions? Do you have any questions? Any contributions?
No questions on my side.
No questions? Okay. If there are no questions, we can proceed. Okay. Everything is clear? We can proceed. Let's proceed. So these were the calculations, and then you can follow them as well. So let's do example number 2. The second example is saying that an isosceles triangular plate of base 3 meters and altitude 3 meters is immersed vertically in an oil of specific gravity 0.8. The base of the plate coincides with the free surface of the oil. Determine the total pressure on the plate and then the center of pressure. Determine the total pressure on the plate and the center of pressure. So what is going on here is that we have a triangular surface whose base, triangular surface like this. Okay, suppose this is the base of the triangle. Okay, I don't know how to draw a triangle, for God's sake. Something like this. Triangle looks like this. And they're saying if this is the base here, this is the base, it coincides with the surface of the water. So if the water of the liquid, of the oil in this case. So this is immersed in oil, and it has got a center here somewhere here. Okay, this is, and this base is 3 meters, and also the height of this is also 3 meters of this triangle here. Okay, and then it is immersed in oil. So the first question is find the pressure by this oil. Let's find the pressure. First of all, you need to know the specific weight of this pressure, which will be given by the density of the oil multiplied by the gravitational constant. But do we know the density of the oil? No, we don't know. What we're given is the specific gravity, which is the ratio of the oil of a given substance, density of the given substance divided by the density of water. Okay, this is, in this case, we're talking about the density of oil. So from this we can obtain the density. From this we can obtain the density of oil as a product of the specific gravity times the density of the water. Okay, and we know that the specific gravity has been given as 0.8 multiplied by the density of water is 1000. So this is going to be 800. This is the density of oil to be at 800. So to find now the specific weight to be given by the 800 multiplied by 9.81. 9.81, you find the product of this. The product of this will be given by 800 multiplied by 9.81. Okay, so this is 7848 Newton meter cubed. Okay, Newton meter cubed. This is also equivalent to 7.848 kilo Newton meter cubed. Okay, this is enough. This is good enough. Okay, this is good enough. So let's work with the first one. We can also work with the second one. It's okay. So let's work with the first one. So the surface area, we also need to find the surface area here now. The surface area of a triangle is BH over 2. So this is going to be the base is 3 times the height is 3 over 2, which is going to give us this is 9 over 2, which is 4.5. So A is a 4.5. A is 4.5. Then what else do we need to know? We need to the x bar. Let me write here, x bar is given by 3 meters. Not 3 meters, sorry. So you go to the table to find the x bar, and the given diagram, it touches the surface of the water. The base coincides with the surface of the oil. Sorry. So you go to the table and check the x for a triangle. Okay. You go to the table and check the x of the triangle, which will be given by the height over 3. In this case, the height is 3, so this is 3, this is going to be 1. So the total pressure now is going to be 7848 multiplied by this. The area was 4.5 multiplied by 1. So when you do this times 4.5, you're going to get 35316. This is the total pressure. This is going to be the total pressure for that. Yeah. So now when you have the total pressure now, which can be written as 3160 kilo newtons. Yeah. So when you have the total pressure now, let's go now find the center of pressure. So center of pressure, the center of pressure will be given by the moment of inertia times divided by the product of this plus x bar. So our job is to find first the moment of inertia for a triangle from the table. So the table will not be given in the exam. The moment of inertia for a triangle is given by base times the height cubed over 36. So this is 3 times 3 power 3 over 36. So 3 multiplied by 3 cubed over 36, which is 9 over 4. So the IG 9 over 4 is equivalent to what? To 2.25. Okay, so the center of pressure will be given by 2.25 over 4.5 multiplied by 1 plus 1. Okay, then when you do that, you're going to get that the center of pressure is at 1.5. At 1 point, center of pressure will be at 1.5 meters, and that's how you get the center of pressure. If there is no question, we can try to look at our next example. Let's look at our next example if there is no question. Is there a question? Hello? You might find you are alone in this class. For the inclined, we have the inclined. Okay. 1. The pressure will be given by the weight of the liquid, the surface area, the depth. The only difference will be that the depth is going to be given by x sine theta. So now this x is actually the normal depth, okay, that we get, the normal depth. Let me write this properly. This is it, x sine theta. So this x here is the normal depth according to the shape, this one here, that is measured the way we are getting the previous x bars, but see, all that the x bar for the inclined, it has got this, where theta is the angle of inclination. That is the only difference. The rest remains the same. So ultimately the pressure will be W A x sine theta, and the number 2, the center of pressure will be given by Ig over A x sine theta plus x sine theta. So this will be the difference between the two. So let's do an example. Let's quickly go through an example. So the question is saying that a 1 meter wide and 1.5 meters long rectangular plane surface is deep in water in such a way that its plane makes an angle of 30 degrees with a free water surface. The top left corner is its least depth and is at 1.5 meters. Determine the total pressure and the position of center of pressure. We are given that this is the free water surface and the immense rectangular object is like this, okay, and it is 1.5 meters here, and this should be okay like this, 1 meters, and the top left corner is 1.5 meters. The center is somewhere here, and this is our x bar. This is our x bar, okay, which should be given by the sum of the first part here, okay, which is 1.5, and the last part there. The first part here and the last part there. Okay, so this is sum of 1.5 plus the last part is the length of this object divided by 2 sine theta, the angle of inclination. Okay, the tiltness is at 30 degrees. So the x bar will be given by 1.5 plus the length is 1.5 over 2 by the sine of 30 degrees. This is 1.5 plus 1.5 over 2 by 0.5. If you do that on your calculator, you find that the x bar will be 1.875 meters. So now to find the total pressure, which is the specific weight of the liquid times the surface area times the depth of the immersed object. So the specific weight of water is 9.81 times the area of this object. Area will be given by area is 1.1 times 1.5, which is 1.5 meters squared. This is meters times 1.5 times 1.875. So the pressure will be given by 1.81 by 1.5 by 1.875. So what we have 27.59 newtons. Okay, kilonewtons. Sorry, kilonewtons. So these are kilonewtons. This will be 27.59 kilonewtons of pressure. Yeah, kilonewtons of pressure. It's kilonewton because we took the specific weight of water to be 9.81 Newton meter cubed, which is equivalent to 9810. This is kilo Newton meter cubed. Okay, so we took this one for kilo, so the kilo should be maintained here, which is starting for 1,000. Next is the specific the center of pressure. Number 2 is the center of pressure, which is defined by the moment of inertia divided by the surface area plus x bar. Here, the moment of inertia of that rectangular object will be given by BL cubed over 12, which is 1 by 1.5 cubed over 12. This is going to give us 0.28125. So your h bar is going to be 0.28125 over the surface area is 1.5 times x bar is 1 times 1.875 plus 1.875. This is going to give us This is going to give us 1.5 times 1.875 plus 1.875. We get 1.975 meters. Okay, 1.975 meters, and that is how we can tackle that question. Thank you. Concerning this, is there any question?
No question.
Yeah, so if there are no questions, that was about our today's class. I was recording this video. I'll share it. Yeah, I'll share it. Thank you for joining. We'll see you in the next class.
Okay, thank you, sir.